Hello again. So let me show you some practical demonstrations of the programs that you saw in the previous lecture. So I copied and pasted the program that we started with in chapter 2. This is the famous Hello World program. So I know we had a slightly different string. I think in that was hello to C. But traditionally, the first program that you write in any language is this hello world program. Doesn't really matter what the string says, what the string is over here. So let me just show you how that looks. So we have the preprocessor directive #include stdio.h. So that's that. This is us telling the preprocessor to include the standard IO library because we're going to use some function from that library. And the function that we're going to use is this printf function for printing stuff to the command line, to the standard output. This line of code is inside this main function over here. And I'm going to try a few variations of this program just to show you what you can and what you cannot do. I know many of you are coming with a background in Python programming, so there's some familiar things here and some not so familiar things, some new things. So let me run this program as it is right now. And there you go, you see the message hello world printed over here. Close this and we're done. And as you can see down here in the error list, we did not generate any errors, but I am going to introduce some errors over here just to show you what that looks like and some of the things that you should definitely not do. So one thing that I perhaps didn't mention here is that we have the semicolon at the end of the line. This is not optional. In C, every statement ends with a semicolon. If I remove this and try to run it as is, I'm going to get an error. So here you can see there were build errors. Would you like to continue and run the last successful build? No. Actually, I want to take a look at those errors. And as you can see, since there is no output, Visual Studio automatically switched me over to this error list tab. And this produced two errors. It says over here, expected semicolon. And if since I selected this error, it'll also show me the line on which this error was produced, and it also gives you the line number over here, line 8. Okay, so the error actually kind of shows up on the next line. So this is a thing. Just because it says line 8 down here doesn't mean that the error has to be necessarily on the exact line 8. The error may be due to something that you did a couple of lines before even. So let me put that back in and run it again. And there you go, it works again. Okay. Another thing is this void over here. Remember I mentioned briefly that void is basically a keyword, and you see that Visual Studio gives us this nice syntax highlighting. It's highlighting different elements of the code in different colors. This is something that this development environment that we use in Visual Studio that does for us. Other IDEs do provide the same function. This is called syntax highlighting. So you can see over here that this string, for example, appears in orange. /n has a different color. It's in yellow, somewhat in yellow. That's because /n is an escape sequence, and this difference in color lets you quickly identify that /n, these two characters over here, have been identified as an escape sequence. You also see that int and void are highlighted in blue, are colored in blue, and that's because these are recognized as keywords specifying data types. Now, strictly speaking, I think I told you before that void basically means no data or no data at all, no data type. Um, just want to show you very quickly. You can actually even skip the void, and your program will still run. Okay, but it's good manners uh, to include the void over here. As a matter of fact, if you look at this program doesn't do any work. It doesn't compute an integer value. So if you really look at it, this program is not producing, not returning any value. So this integer return type before main um, kind of inappropriate. So you could also replace this with void just to kind of clarify that nothing is being returned. And as you can see, this will work too. All right. However, usually we want to, usually when we write functions, we do make them return some value. And the reason for that is that even if a function is not doing any work and producing any results that it has to return, usually we still like to return a value just kind of to let users of that function know whether the function worked correctly or if something went wrong. So in this case, we're not doing any of that. But um, uh, uh, that's why, in any case, even though this function is not returning any value in this example, we still set the return type of the main function to integer. All right. Um, so let me show you what happens if we skip the slash n, the new line character. Look at the output. If you notice, before we had a blank line after hello world. So here we don't see that blank line because we skipped the slash n character. So the rest of it over here, these last four lines that you can see, these are basically uh, 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 added on by the compiler. All right, and put in multiple slash n's. Do that. Can add even more blank lines after that. So one blank line for each slash n. Let me reproduce the exact example we had in the slides. I'm changing the message to what was it? Welcome to C. Welcome to C. And let me put each of these words on a separate line, like we did in the slides. Let me run that again. There you go. The output is welcome, new line 2, new line, C exclamation mark, new line. And can even do the same, or we can even, same thing, but use multiple printfs, multiple printf statements. So for example, can put the 2 and the C exclamation mark into separate printf statements like this. Oh, there you go. All right, and this will produce the exact same output. See, it looks identical. So you can see that there are often many different ways to do the exact same thing, to do the same work in programming in general. So printf, that's one statement, that's the function that we use in C for output, for printing something to the screen in this case. Um, Another language kind of built on C is C++, and C++ is what we call an object-oriented language. Allows you to organize your code in such a way that it makes it easier to reuse it, easier to protect certain parts of your code from misuse, from accidental misuse. That's something beyond the scope of this particular course, this particular class. But occasionally you'll see examples of C code that will use something other than a printf function to print to screen. And what you'll see is something called C out statement. Okay, so I'm going to now use syntax which technically is not C, it is C++. And this will not work. This is not enough because this C out that you see over here, this is not, by the way, this as you can see, functions involve use these round parentheses. C out is not a function. Actually, technically, it's called something. It's called a stream. So what I'm going to do is the C out is not available in the standard stdio.h library. So for that, I have to include something else. I have to include another library called iostream. Okay, and not only that, I have to put this in front of it. So std 2:, cout, two less than signs, and followed by this string over here. And you can see that both printf and cout do the same thing, but they have very different syntax because cout is something we call a stream, an IO stream, and that's something that came with C++. But occasionally you'll see C code that borrows the use of streams, that borrows the use of cout from streams. This may even look a little awkward because you have these two colons in there. You have to put this std in front of it. What you can also do is you can shorten the syntax a little bit if you're going to use cout regularly. So within each library, in this case, streams and functions are organized into namespaces. Now, if we're going to use the std standard namespace, frequently what we can do is we can include this line using namespace std, and that allows us to skip the standard 2:, in front of cout. Run this again, and you see the output is still the same, still works. So this is all the this and another stream, an input stream that when we talk about inputs a little later. Input and output streams, C and Cout, are basically the only C++ syntax that we're going to look at. It's kind of very basic stuff. So although we're studying C, I wanted you to know this because sometimes you see C++, the use of these these IO streams, you'll see these mixed into what is otherwise C code. All right, to take that back out. All right. So you also saw there were some other escape sequences other than /n that are occasionally used. So let's say one of them was /t. So it's an escape sequence for a tab character, right? So let me run that for you. And let's look at the output. And you can see that the message welcome to C has been moved forward in this case by 8 characters. Okay. If I want, I can put /t in between the words of my string. I can try to run that. I have welcome to, oh, hold on, forgot something over here. Welcome tab /t. Yeah, okay. So the tab just moved the 2 actually by nothing forward. That's why it's, if you've used Word, you know how this works. But if you're very particular about the spacing or in the output string that you're trying to produce, it's better to just use space characters like this. So the use of the tab escape sequence can be a little hard to predict at times. So let me leave this one /t over here. Another escape sequence that you saw was /a. Remember I told you that this produces an alarm or a sound. So let's see what happens if I run this. Let's listen to the sound that we get when we run, when we use the /a escape alert escape sequence on a Windows computer. I hope you heard that. That was the Windows. That was a Windows sound that you usually get when you get an error or a warning message. So in Windows, that is how the /a escape sequence manifests itself. And let me just give you a few other examples. There was another sequence. If you want to include double quotes. Now, if I just put in the double quote over here, you can see what happens. Basically, printf is expecting a string in here, right? The string begins at the first double quote, it ends over here, and all of this is not being recognized as a continuation of this string. If I run this, I'll get an error or a warning at least. Let's see. There you go. Got an error because this is not a proper string over here. So let's say I want this double quote to show up inside the string when I print this message to screen. Let's say I want it to look like this. I want to put the C into double quotes. If I want to do that, I have to use the escape sequence for double quotes. So now this double quote over here is not being taken or interpreted as the end of the string, but it is being interpreted as part of the string. Let me run this again. There you go. Welcome to C with C in double quotes. No errors, nothing. Take this out because so as not to confuse anyone what it does. And let's say I want to insert a slash. If I do that over here, you can see welcome to C still with the double quotes, but the slash did not show up. It's because a single slash and the character following it will be interpreted as some kind of escape sequence. Now, slash space doesn't mean anything, but in any case, the slash did not print out in the screen or on the screen. So if I want to insert a slash over here, I have to put in 2 slashes. That tells the printf function that, hey, this is not an ordinary slash, and it's not 2 slashes. This is supposed to be interpreted as a single slash as part of the string. Run this. There you go. Welcome /space to C. And this is how you can insert a backslash character into a string.